Hello students, welcome to today's class. Today we are going to do all sort of numerical problems for the chapter solution. And I'm telling you students, all of these problems is very important for your upcoming exams. So let us start problem number 1. The problem says the vapor pressure of pure benzene at certain temperature is 0.850 bar. A non-volatile, non-electrolyte solid weighing 0.5 gram when added to 39 gram of benzene, vapor pressure of solution is 0.085 bar. Find the molar mass of the solid. Okay. Now, what to do in these numerical problems? I have already told you always need to tabulate all the data given in the question. So, data number 1, vapor pressure of pure benzene, pure state. That means it will be P0. It will be P0 equal to 0.850 bar. Secondly, a non-volatile, non-electrolyte solid, that is the solute. So, what is the weight of the solute? The weight of the solute is 0.5 gram. So, weight of solute equals to 0.5 gram. When added to 39 gram of benzene, what is this benzene here? This is the weight of the solvent, weight of the pure solvent. So, weight of solvent equals to 39 gram. And vapor pressure of the solution? Vapor pressure of the solution is 0.085 bar. That means P solution is 0.085 bar. So now we are having all the data. What is asked in the question? Find the molar mass of the solid. That means find the molar mass of the solute. So M solute is asked. Now see the data given. Which formula will be applied now? The formula of Raoult for relative lowering of vapor pressure. Yes. So the formula will be P0 minus PS by P0 equal to X2. I have already derived the formula in the previous video. That will be N2 by N1 plus N2. And here, can we neglect this N2 with respect to N1? Yes, obviously, because weight of solute is 0.5 and weight of solvent is 39. There is a huge difference. So, we can easily say the solution is dilute. So, here, as the solution, you need to write this data, is dilute, N2 much smaller than N1. So finally what we are doing? N2 by N1. The formula is then weight by molecular weight for solute and M1 by W1. That means weight by molecular weight of solvent. We have already derived this data. Now please put the values and we will now get the answer. That is weight W2, weight of solute is 0.5 into molecular weight of solvent. Molecular weight of solvent, that is benzene. It is. Let us calculate the molecular weight over here. M of benzene, that is C6H6, 6 into 12 plus 6 into 1, that is 72 plus 6, it will be 76. It will be given in exam or you can calculate it. So let us put the value now. This is 76. M2 we don't know. M of solute and W1 weight of solvent is 85, it is 39 gram. It is 39 gram. Now we need to calculate all the data, and the answer is coming to be 170 gram per mole. Please do the calculation with your calculator and don't miss this calculation part. Okay. So this is problem number 1 and it is very easy. Now let us go to problem number 2. Now this is a problem of type 2. Here the problem says a solution of lactose containing 8.45 gram of lactose. Let us write the data. In 100 gram of water. So here water is the solvent and lactose is the solute. So what is weight of solute? That is weight of solute. We denote weight of solute as 2, suffix 2, and weight of solvent as 1. So W2 equals to 8.45 gram in 100 gram of water. That means weight of solvent W1 equals to 100 gram. Has a vapor pressure of, a solution of lactose is having a vapor pressure of 4.559 mmHg. Okay, so the vapor pressure of the solution, that is PS, equal to 4.559 mmHg, and vapor pressure of pure water, that is P0, equals to 4.579 mmHg. Calculate the molecular weight of lactose, that means molecular weight of solute. Now students, you will ask me why same kind of problem we are repeating. All the data are provided. In the previous problem, it was there, calculate the molecular weight of the solute only. Here we are also calculating the molecular weight of solute. So what is the difference? See one thing, is the solution can be considered to be diluted? Can it be considered? See, 8.45 gram of the solute is being dissolved in 100 gram of water. So it cannot be considered as a dilute solution. In the previous problem, we had 0.5 gram of solute and near about 35 gram of benzene. So that was a dilute solution. Here we are having 8.45 gram of solute. This cannot be a dilute solution. So here the problem comes with little modification where we cannot neglect weight of or number of moles of solute with respect to number of moles of solvent. So what will it be? Same P0 minus PS by P0, same thing, relative lowering of vapor pressure equal to X2, and here we can write N2 by N1 plus N2. Here as the solution is non-dilute, we cannot neglect N2 with respect to N1. We need to consider N1 plus N2. So now the problem becomes very easy. So one thing you have to do, you need to identify if the solution is dilute or not. For a general case, I am telling you, if weight of solute is less than 1, then we will consider the solution to be dilute. And if it is not, then we cannot neglect N2 with respect to N1. Now, weight number of moles equals to weight by molecular weight. Again, W1 by M1 plus W2 by M2. We need to calculate the molecular weight of lactose. That means we need to determine this M2 part. So let us put the data. W2 is 8.45. M2 we need to determine. Here W1 is 100 molecular weight of water. You need to remember, I think all of you remember, it is 18 molecular weight of water plus W2, that is 8.45 again, and M2 we don't know. So the calculation is little harder. You need to practice this kind of calculation, and the answer is coming to be 347.04 gram per mole. Now we will go for problem number 3. Let us see the problem. 0.70 gram of organic compound when dissolved in 32 gram of acetone produces an elevation of 0.25 degree on boiling point. Calculate the molar mass of the organic compound. So 0.70 gram of organic compound. So this is the weight of solute. So let us write here, this is weight of solute, that is W2, when dissolved in 32 gram of acetone. So this 32 gram of acetone is weight of solvent, that is W1, produces an elevation of boiling point. So this is a problem of calculating the delta TB from Raoult's law of elevation of boiling point, and this elevation is of the quantity delta TB is of 0.25. This is delta TB. Calculate the molar mass of the organic compound. That means the molar mass of the solute present, of the solute, this part. So which is asked in the question? M2 or M of solute is asked. The given data, Kb of acetone or Kb of the organic compound is given, that is 1.72, and the unit is mentioned over here. So what we have to do now? We need to put the formula directly. The formula is delta TB equals to Kb into Cm, where Cm is the molar concentration of the solution. This part we have already modified, so I am not going to details. Kb into Cm, that is weight of solute W2 by M2 into W1 by 1000. So now let us put the data over here. Kb equal to 1.72, W2 equal to weight of solute, that is 0.70, M2 equals to M2, that is the data which we need to know, 1000 it is given, and W1 weight of the solvent, that is acetone, is 32 gram. Now we need to solve this. The solving is extremely easy, and here the delta TB is 0.25. So students, let us solve the problem. Please solve it. So here molecular weight M2 of solute is going to be 150.5 and gram per mole. So again this problem is only the application of formula, nothing else. You just need to know the formula. You need to apply the formula which you have already learned, and then the problem is easy enough. Let us go to the second problem of similar kind. The freezing point of the solution containing 0.3 gram of acetic acid. So 0.3 gram of acetic acid, that is weight of solute represented by W2. It is 0.3. Acetic acid in 30 gram of benzene. 30 gram of benzene. So this 30 gram represents weight of solvent, that is W1, is lowered by, freezing point is lowered by 0.45 Kelvin. So this is delta TF. Now we need to calculate the Van Hoff factor, and the Kb is told, that is 5.12. Now this problem includes this term, what is It is Van 't Hoff factor. Now, why Van 't Hoff factor is asked over here? See, the solute which is mentioned over here is acetic acid. I have told you students, the solute which can undergo a electrolysis, or the solute which can dimerize to create another molecule, that is not a ideal case. Here, acetic acid generally dimerizes by hydrogen bonding. So, for solution like NaCl, is NaCl an electrolytic, non-electrolytic solution? No, NaCl can produce Na plus and Cl minus. But in case of Raoult's law, we always need non-electrolyte, non-volatile solute. But NaCl is not a non-electrolytic solute. It is an electrolytic solute. For acetic acid, what is the drawback of acetic acid? See, acetic acid is having the formula of this. So, one acetic acid molecule can easily combine with another one through this hydrogen bonding. So, this acetic acid we cannot get singly in a solution. If we add suppose 10 mole of acetic acid, we will get 5 mole in the real case. So, for the real cases, the factor which we have to introduce is Van 't Hoff factor. So, this is the case for real solutions. So, Van 't Hoff factor we need to calculate. All the data are given. So, again we need to just put the values. It will be for delta TF we are calculating. So, it will be KF into, again, W2 by M2 into 1000 by W1. And what is the extra factor over here? That is the Van 't Hoff factor. The Van 't Hoff factor which will determine the amount of deviation of this real solution from the ideal solution. Okay, so see, all the data are given. Delta TF equal to 0.45. KF is already given, that is 5.12. W2 is given, weight of solutes, that is 0.3. M2 is given, M2 is weight of benzene. It is weight of acetic acid. M2 we need to calculate, we are calculating M2, that we don't know, we need to calculate. Then 1000 and W1, that is weight of solvent. What is the weight of solvent there? This 30 gram. 30 gram. So see, all the data are given and we just need to find this I. So the value of I will be 0.527. So this will be the Van 't Hoff factor. See, basically acetic acid always dimerizes. So Van 't Hoff factor should be half. Here the Van 't Hoff factor is coming to be 0.5, that is half only. So you can get the numerical problem is right. This problem is about the osmotic pressure of a solution, that is also a colligative property. Let us go through the problem. The osmotic pressure of 0.25 molar of urea solution is 2.67 atm. What will be the osmotic pressure of 0.25 molar solution of potassium sulfate? Now, this can be an extremely easy problem if concentration was told, pi have to be calculated and temperature was told, because we already know there is a formula of pi equals to CRT, where C is the concentration, R is the gas constant, universal constant, which all of us know, and T is the temperature in Kelvin unit. This is the easiest formula to calculate osmotic pressure. But this segment is having two parts. First, the osmotic pressure of urea solution is told, and with the help of that osmotic pressure, we need to calculate osmotic pressure of potassium sulfate. So how to do it? Let us go through the solution. And the problem is important enough because it came in 2010. So, pi of urea is told, that is 2.67 atm. 2.67 atm. The concentration of urea solution is also told. So, C of urea equals to 0.25 molarity. Now, what will be the osmotic pressure of this? So, from the equation 1, this is the equation 1 to calculate osmotic pressure. Suppose pi of urea is told, C is told, R we already know. The data which is missing from the part 1 is the temperature. Now, if we don't know the temperature, how can we calculate the osmotic pressure of potassium sulfate? So, in the first part, we need to know the temperature. So, let us determine that. Now, R, what will be the value of R now? Will it be 8.314? R is having the value 8.314 in joule unit. But here, the pi have to be calculated. That is in the unit of atm. So, the value of R cannot be taken in joule unit. So, what will be the value of R? It have to be taken in liter atm units. And the value is 0.082 liter atm, Kelvin inverse, mole inverse. You need to know all the values of R. I think all of you know this from class 11 only. So I'm writing the value 0.082 liter atm, Kelvin inverse, mole inverse. So we are putting this value and temperature we need to calculate. This is a very simple calculation and the temperature is coming to be 130.08 Kelvin. Now see, we already know the temperature from the part 1. Now, concentration of potassium sulfate solution is same, that is 0.25. So again, if this is part 1, part 2. So again, if we apply the same formula for potassium sulfate, that is K2SO4, what will it be? Pi of K2SO4 have to be calculated now, the osmotic pressure of K2SO4. Concentration of K2SO4 is same, that is told in the question. R we already know, and the missing data, that is T, we have determined in the part 1, that is 130.08. So now we will put the value 0.25, 0.082 and 130.08. So the answer, the pi of K2SO4 will be of the value of 8.01 atm. So this is a very simple problem, but we need to use the data obtained from part 1 in the solution of part 2. So this is type 1 problem of osmotic pressure. Okay students, now what will be the next problem? Now the next problem is the problem which came in 2015. The problem states if 1.71 gram of sugar molecular weight is mentioned is dissolved in 500 ml of aqueous solution at 300 Kelvin. What will be the osmotic pressure of the solution? So again this problem comes from osmotic pressure. That means that pi equals to CRT part. Sugar, so it is not an electrolyte. So there is no need to introduce Van 't Hoff factor. So 1.71 gram is weight of solute, that is W2. Okay. Now is dissolved in 500 ml of solution. So volume in ml of solvent, that is aqueous solution. So the solvent will be water obviously. So volume in ml is mentioned over here, that is 500. Temperature is already mentioned. You need to calculate the osmotic pressure. Now see, pi equals to CRT. This C is the molarity of the solution. But molarity is not mentioned over here. So this will be the formula relating weight of solute and osmotic pressure. That means the modified formula of pi equals to CRT. How can we modify this? Let us recap once. Pi equals to CRT, as C equals to concentration, so it will be number of moles by volume in liter. We know this formula from class 10 onwards. Concentration equals to number of moles by volume, and then number of moles equals to weight by molecular weight. So number of moles equals to weight by molecular weight, and it will be V in liter. So C can be modified like this, and then if we replace the concentration term with this formula, that means the weight of concentration of the solution. That means this will be W2 M2, weight of solute by molecular weight of solute into 1 by volume of solution in liter into R into T. We can easily get the osmotic pressure. Now let us put all the values. So pi will be equal to W2, that is 1.71, M2, that is weight, molecular weight, which is mentioned over here. This one, 342 into 1 by, see, volume in liter. The volume is mentioned over here in ml. So we need to convert it. So the volume will be 0.5 liter into R. We have already learned it will be 0.082 in liter atm unit, and temperature is, it is given 300 Kelvin. Suppose if the temperature is given in Celsius, degree Celsius, we need to convert the temperature in Kelvin first. So let us calculate, and hence the pi will come to 0.246 atm. Extremely easy one. And see, this problem came in 2015, so it is easy enough to gain marks in exam. Now let us come to problem number 7, which also came in 2016. A 10% aqueous solution of cane sugar, molecular weight is mentioned, is isotonic. A very new term is isotonic with 1.745% of aqueous solution of urea. Find the molecular weight of urea. Now what is this isotonic? So the solution having similar osmotic pressure will be termed as isotonic solution. Now the solution of sugar and urea are isotonic. So we can easily write pi of sugar equal to pi of urea. This is already told in the question. This is the mathematical form of the representation. So pi of sugar we have known. 10% aqueous solution of cane sugar. That means if the volume of cane sugar of the solvent is 1 liter, the amount of sugar dissolved will be 10 gram. So can we write this? Concentration of sugar into RT, temperature is mentioned, and concentration of urea into RT. Here the temperature is not mentioned, so we will just take a moderate temperature. Now here concentration is not mentioned, but the weight is mentioned. So what we can do? We can do just like the previous problem. Weight by molecular weight into 1 by volume in liter. So let us write this. Weight of sugar by molecular weight of sugar into 1 by volume of solution into RT equal to weight of urea by molecular weight of urea into volume of solution into RT. The weight of solvent will be 10 over here. The molecular weight is already mentioned, that is 342. Now what will be the volume of solution in liter? That it is not mentioned over here. But see, this is a 10% aqueous solution. That means the volume of solution will be 100 ml for sure, because it is 10%. Percentage is provided over there. So we have to convert 100 ml into liter, that is 0.1 liter equal to weight of urea that is provided. Weight of urea it's provided, it is 1.745%. 1.745 divided by molecular weight of urea needed to be calculated, and again the volume is percentage is given, so 0.1 liter. Now all the data are provided, so molecular weight of urea now can easily be calculated, and it is 59.98 gram per mole. So let me end this video with osmotic pressure, and in the next video we are going to solve lots of problems mainly related with Van 't Hoff factor. Till then, goodbye.